Good evening, UofT's Astronomy News and Updates channel. Today we're going to explore the OSIRIS-REx mission, the first American spacecraft to collect samples from an asteroid. OSIRIS-REx stands for Spectral Interpretation Resource Identification Security Regolith Explorer. This one in particular successfully collected samples from an asteroid Bennu in 2020, and samples are set to arrive on Earth later on in 2023. The mission had 5 main goals as written by NASA. Number 1, returning with at least 60 grams of material from Bennu, successfully mapping the global properties, chemistry, and mineralogy of Bennu. 3, properly documenting the texture, morphology, chemistry, and spectral properties of the sample site. 4, measuring Bennu's orbital deviation as a result of non-gravitational forces known as the Yarkovsky effect. And 5, characterizing the integrated global properties of the asteroid for comparison with ground-based observations. Now, before we get into specific details of this mission, let's take a look at the journey NASA has gone through in the process of collecting these samples. So, NASA kept track of all the following important dates. OSIRIS-REx successfully launched on September 8, 2016, and completed a flyby of Earth the following year on September 22, 2017. OSIRIS-REx flew 78,146,869 kilometers, or about half an AU, before reaching Asteroid Bennu on December 3, 2018. However, it would take until October 20th, 2020 before it actually collected a sample from the asteroid. After roughly 7 more months of exploration on the asteroid, OSIRIS-REx left Bennu to return to Earth on May 10, 2021, and NASA eagerly awaits for September 24, 2023, when a sample will land on Earth. Now, the sample was not the only part of Bennu OSIRIS-REx collected. When it first arrived on Bennu way back on October 20th, 2022, it had gone through a maneuver called touch and go, aka TAC. Through images sent from OSIRIS-REx, the mission team was able to confirm that the spacecraft collected more than the sufficient amount of matter from the asteroid, fulfilling one of the mission's main goals, gathering at least 60 grams of Bennu's surface material. As one can see from the timeline previously covered, there is a gap between OSIRIS-REx landing on the asteroid Bennu and it finally collecting its sample. The gap exists because OSIRIS-REx spent those 7 months navigating the asteroid, which allowed the mission team on Earth to survey the asteroid and decide where the sample should be collected from. The mission team took note of the fact that the surface of the asteroid was very rough, with many boulders, which resulted in various dangerous potential spots, which the mission team had to avoid. It also gave crucial information about Bennu that helped accomplish a few of the main goals of the OSIRIS-REx mission. In the end, the mission team honed in on a northern crater nicknamed Nightingale. The crater was considered to be young, also 140 meters wide, with lots of rocks and dust that were freshly exposed, which would be key in eventually unveiling the history of its asteroid. So, why is the sample so important? The developers of this mission look forward to analyzing the sample with hopes that it will reveal more about the formation of the early solar system and how life in general began. Astronomers currently believe that the solar system started out as a cloud of gas and very fine dust grains rotating. Scientists use the shape of this cloud to explain why the solar system orbits the sun in the same direction along similar planes. Young stars in space today are still observed to have protoplanetary disks, which are present for a long enough period of time to set a planetary system up. The sample from Bennu could help strengthen the current hypothesis that asteroids in the solar system grew over time from the combination and collisions of fine grains, dust, ice, and other particles. On top of that, they hope that this sample will help scientists understand and prepare for potential asteroids like Bennu that could collide with Earth in the future. Fortunately, the mission was extended until April 2022. The mission name will change to OSIRIS-REx since the spacecraft will explore the Apophis asteroid. This 370-meter diameter asteroid is particularly exciting because it is an S-type asteroid made of silicate and nickel-iron materials, which will finally enter the Sun's orbit and will be within 32,000 kilometers of Earth in 2029. This concludes the UofT Astronomy News and Updates channel segment on OSIRIS-REx mission. Stay tuned for our next update about what we know about the Andromeda Galaxy. Good night.